So again, we're using the first derivative test. This time our function is not just a regular polynomial, it's a chain rule. So to find the first derivative, we will need to use chain rule. 3 exponent comes down. X minus 2 squared now, multiplied by derivative of the bracket, which is 1. Simplify that out. We need to know exactly where this derivative is going to equal 0, so we set it equal to 0. We can divide both sides by 3. We can take the square root of both sides and move the 2. So we're in luck. There's only one critical number, x equals 2. So when we go to draw a number line, we only have 1 at 2. This function, this derivative, is going to be 0 when we plug in a 2. Now we need to look at numbers to the left of 2 and to the right of 2. I'm going to pick 0 and 3. Again, no specific reason why those two, so long as one of them is on the left of 2, one of them is on the right of 2. So now I need to look at my derivative and see what the value is when I substitute in 0. And I get 12. 12 being a positive, so when I substitute numbers in on this side of 2, I'll get positives out as my answer. Repeat the process with 3. And again, I get a positive. So this sign analysis looks a little bit different than the last one. Last one we had the signs changing from positive to negative and back to positive again. Here we don't actually have a sign change. How does that affect us? Well, if we're increasing, decreasing, not at all. We're increasing from negative infinity to 2, and then again from 2 to infinity. I know it might be tempting just to put negative infinity to infinity, but what happens with this function? It actually physically stops increasing. It levels out at 2. So it's not increasing all the way. It levels off to a slope of 0 at 2, and then it turns back and goes increasing again. We need to account for that in the sign analysis. Decreasing, that's when our sign analysis is negative. We don't have that. So this function is never decreasing. Maximum, minimum, well, we don't have any of those either. Why don't we have any of those? This derivative doesn't undergo any sign changes. To have a minimum or a maximum, the derivative has to change sign from positive to negative or negative to positive. This one doesn't do that, so we don't have any min or max.